Let's do part of it in costume. All right. Oh, shit. Oh, let me turn this. All right, should we do this? Get started here. Get started. See now I'm embarrassed to take it off because my whole head is soaking wet, my shirt's soaked through. I might have to though. We'll see. Okay. So this guy right here, we're given that this is 20 feet per second to the right. So this guy's got 20 feet per second to the right. I'm recording it. Yeah. 20 feet per second to the right. And then it asks us, what is the velocity at A, right? And then what is omega AB? And AB is this, that bar going across. So what's omega AB and what is the velocity of A? Oh, I can't do it. I can't breathe. No, I don't want to. I don't want to. I don't want to. That's too much fun. Okay. Okay, so then, what do you think what do we start with here? Huh? Point E. Oh yeah. But see, but we know this guy though, right? I mean, really, you can start wherever you want, as long as you stick to the rules and go. But I would start at D, right? Or C, right? Because they tell us what VC is. Oh God. Okay. If I pass out, somebody jump up here, help me out. Okay. So, I know I gotta get omega. I gotta get omega C, right? I have to see how that thing's rotating. If I know this VC is 20 feet per second to the right, and I know the velocity of D is 0, so I'm gonna go D to C, right? If I go D to C, then I can figure out how omega C is rotating. Okay, so let's do that. Whew. Okay, I can't do it. I can't breathe.
Oh my God, it's like a hole.
Oh yeah, it's a wig and everything. So
You sit on a throne of lies.
I know. Oh shit, hopefully there's no kids in here, right? Young kids. I just ruined it. Just ruined it for the young kids. Spoiler alert, people that are here. Spoiler alert, I wasn't the real Santa. Well, they're 14 and 17, so I hope that they're. I hope. Oh, look at you! Look at you! You dressed up. You came in late, right?
What?
You came in late.
I did.
Yeah, it looks great.
Thank you.
Yeah.
My circuits TA told me that I can't get extra credit for this. It's very sad.
Can't?
I can't.
That's rude. Circuits is. Oh yeah, I'm soaked through. It's soaked through. Okay. Whew. All right, so let's do it. So we're gonna go D.
I don't think there's any double.
All right, we're going to C from D. All right, so you just come down. You say VC is equal to VD plus omega. What do I call it? Omega C crossed with RC is seen from D. Right. So I'm going to step from D to C. So. Okay, so the VD is 0. Oop, that guy's 0. And then, are we doing on time? Oh yeah, we got plenty of time. Right, so then just expand this. So this is equal to omega, oh, I'm gonna go down one line actually. This is omega C in the K. I would just assume it's positive, omega C in the K, and I'm gonna cross that with RC seen from D, which is, the diameter is 5 feet, so it crosses with 5 in the J, right? And then VC is equal to, right, that's constrained. VC is just 20 in the I is equal to this, right? And then this would be 20 in the I is equal to negative 5 omega. Omega C, right? In the I. Right? So everything's in the I direction. And so I can get omega C. Omega C is just equal to negative 20 over 5. Right? So now I know what omega C is doing. Or, right? Or rolling wheel, which is VA is equal to negative R omega C. Right? You could just jump right to it. If you notice it's a rolling wheel, just jump right to it. You don't have to do the step, but you can always do the step if you want. Right? Am I good? Everybody cool? We're doing this right? Okay. So now I know velocity is C, right? Or no, I already knew velocity is C. Now I know omega, right? I know omega of C, right? And it's going negative 20 over 5, so it's rotating that way, right? So it's rotating, and rotate your fingers around, it's going into the board, right? So now that I know that omega, I could go to B, right? I can't jump over here yet. I have to go to B first, because the only thing that's attached to this over here is B. So I got to go to B, and then I go from B down to A, and then I'm done, okay? So what do I know? Where's places I know? Huh? Yeah, D. I know D and C, right? Is that what you said, D and C? I don't know. I'm after A. Oh, it's Australian thing. He's trying to say A, but then he keeps saying E. Or he's trying to say E, but then he keeps coming out as A. Yeah, it's okay. Where's E? Oh yeah, you know E over here. Yeah, we don't go there though. Okay. So but we do know that. So I can go from D to B, right? I can go D to B, or I can go C to B. Right? I can go either way to get to B. I'm gonna go D to B, just because I want to. Right? You can go anywhere on that body you could go. So then I go after VB. Right? VB is equal to VD plus omega C crossed with RB as seen from D. Right? So VD, that is 0, right? Because it's still at the bottom there. And then this omega C is just equal to, this is equal to negative 20 over 5 in the K direction. And I'm crossing that with RB as seen from D, which is 10 in the J. Oh, like I like how I don't do 20. I don't calculate 20 over 5. I left it as a fraction, right? Because I didn't have a calculator, right? That's 4. That's 4, right? It's so hard to do without a calculator. Yeah. So that this is equal to 40 in the I, right? And it's feet per second, right? So now I know the velocity of point B, right? Yeah. Everything's good. So this is telling me that B is going to the right at 40 feet per second. And I buy that, right? Because it's going to go, the top here is going twice as fast as what the center is doing. And I buy that, right? So now I know B. Now I got to take a step from B to A now. Now I could do that. I go B down to A, right? So let's do that. So they say VA is equal to VB plus omega BC crossed with RA is seen from B. Okay. I know what VB is. I just solve that. That's going to be, I'm going to do it down below here. So this would be 40 in the I plus omega BC. We just assume a positive K. Okay. And I cross that with RA is seen from B. RA is seen from B. I'm at B. I'm going down to A. So I'm going to the left 15. So negative 15. And then I'm going down 5. Right? Because I'm up at the top, I'm going down 5. So crossed with negative 15 in the I minus 5 in the J. Right? And I carry that out, and I get 40 in the I minus 15 omega AB in the J plus 5. So I'm just doing, I pre-did my cross products. Yep. AB on everything. I wasn't done yet, Mark. Was it you, Mark? Who, yeah? Derek? Oh, it was you. I was like, God, that other person sounded exactly like you. AB. Yep. The omega AB plus 5 omega AB in the I. Right? So just carry out that cross product. I just go through this, right? And that's in the I, and I carry out this cross product. I cross with this guy, these two guys. I cross, and then I cross with these two guys, right? And they're out of order here, but that's okay. Now, once I get to this step, I lump my terms, right? Also, I do know this. I know that the velocity of A is only in the I direction. So VA in the I plus 0 in the J. That's getting messy. That's getting messier than usual. VA in the I plus 0 in the J, right? Because it's just rolling along, so I know that it has no. It's not being lifted up. That center, it's just rolling, so it's not being lifted up. So that's that. Okay, so now I lump my terms, and I could actually, I'll do that. VA in the I direction is equal to 5 omega AB plus 40 in the I minus 15 omega AB in the J. Okay, so I lumped my I's and I lumped my J's. And then now you look in the X. Okay. X direction, we get VA is equal to 5 times omega AB plus 40. And then the Y direction, I get 0 is equal to negative 15 omega AB. So that tells us there that omega AB is equal to 0, and then VA is equal to 40. Right, and that's the two things we are after. Omega AB and 40. Sick. Right? So all these problems are solved the same way. It all is involved. You start out at a point that you know something about and work around. Even if you mess up, right? And even if you start on A, that was my attempt to do it. Even if you start here, that's fine, right? It all works. You just would get hung up because you're like, oh, I want to go to there, but I don't know what A is. But then just keep going to B, and then B down to C, and then B down to D, and then every time just imposing your constraints as you go along. And as long as you stick to the rules, it's gonna be fine. You'll still get the right answer. Just some ways ends up being a little bit easier than others. Okay? Any questions about that one? Right? So yes, Mark.
Is it wrong to assume that VA in the I would be the I?
Yeah, I mean, it wouldn't be. Yeah, it's a great question. It wouldn't be if it wasn't at this instant right here, right? Because what's happening. Yeah, that's right. Like if you think what's happening, it's rolling up, right? It's rolling up. So they're not equal to each other, and then until just right there. And the reason right there is because that's when this thing stops rotating, and then after this, it's gonna start pulling it this way, and it'll pull that one even faster. So it just happens to be at the point right where it was rotating. It was rotating up, and then it's gonna start rotating down. And we caught it right in the middle. And so it just happened to be that way. I wouldn't notice that. Maybe if you noticed it and were like, oh yeah, I know that this thing isn't gonna be rotating because it's up there, it's on the bifurcation point, right? Between the two behaviors. If you didn't know that, then you guys sound smart. I'm a doctor. I'm a doctor. So, right, but if you didn't notice that, then you stick to this plan. Yeah. Okay, second part. So then also keep in mind, right? You have basically 25 minutes to do this. This is like the level that we'd be doing, right? I put in the accelerations as extra credit because we ain't got time for that, right? You remember that how much accelerations, it took a lot of time to do accelerations, right? In this particular case, I was asking for a very specific, this guy right here, right? So then the acceleration at the bottom of a rolling wheel, like you would have, if you had that written down, you would have seen that and you'd be like, oh, I know the acceleration at the bottom of a rolling wheel is just r omega squared, right? Because it would have no acceleration in this direction because it's not slipping. And so the only component, if you remember when we did rolling wheels, was just in the vertical direction right there, and it ends up being just r omega squared. And so you'd have to do a little something to figure out if A is 40 to the right, you have to figure out what omega of this disk is, and then once you get the omega of a disk, then it's just r omega squared is the thing. I feel like you guys are judging me up there, the refs, right? T, technical, they look at it like you're angry. So let's do that really quick. Right, the extra credit, just so you could see it. So you got to keep in mind, I can't go too crazy. I can't give you, I wish I could give you the sun gear, right? I wish I could do it because that would really separate you, but we don't have time for that, right? We don't have time. So it's got to be something pretty straightforward. AE, right, is just equal to, what is it, negative omega squared, 10 times R. RA is seen from E. Right? And then so I have to figure out what omega A is first. Oh, sweet. Okay. So then omega A is equal to just V over R. Negative V over R. So this ends up being, right, that's 40, and I divide it by the radius is 5, which ends up being 8 radians per second. Oh, and negative 8 radians per second, right? And then that goes into this equation up above, and that's where you get it, right? 8 squared times 5 in the J ends up being 320 in the J feet per second. So that's why, I mean, that one was fair for an extra credit problem, right? Just because you had to be able to see, you had to remember that the acceleration was only in the vertical direction, and the only acceleration is the centripetal acceleration, which is just omega squared times RA seen from E. Is there a minus there? Must not be a minus. Whatever. I mean, I know that it's got to be accelerating up. I think this maybe's no there. Because it has to go up. Anyways, that was the extra credit. Cool? Any questions about that one? Let's do the next one. This guy. Okay? It's similar to, actually really similar to the first problem that we did when we did F equals MA, right? Really close to be the same one. It's just the one we did for the very first problem was just that bar. Actually probably harder because we had to figure out what the mass center was and what the moment of inertia was and things like that. Side note, right? You don't write all these down. Right. This case, I'll put them up at the top, the relevant ones that you may or may not need. I might throw you off. I might put one in there you don't need, but I'll give you ones that you need. Like in this particular example, right? You don't actually need this bar, but you do need what's going on over there. So don't worry about writing it all down. Okay. All right. So this is it, right? You're like, oh my God, what do I do? Right? So you panic first, and then you look to see what your neighbors are doing, right? And then you settle down and you stick to the plan, right? And then the plan is we're gonna do a free body diagram, possibly do some moments of inertias and stuff like that along the way. Let's do that. We'll stick to the plan, doing it right. Oh yeah, mass props. I'm gonna do mass props to begin with, right? So when this guy's going, right, just to lay it out, I mean, it's going to be rotating about a fixed point. I always like to find fixed points because it just makes your life a little bit easier, right? And so there's a fixed point up at O. So if I get I about O, when I sum my moments about O, it just makes the moment equation just a little bit easier. It just makes it so the reactions don't show up in it. You could do it about the mass center if you wanted to, okay? And it's totally fine. So there's a fixed point right there. So then what I do is I look over here and I say, what matches that? And you got to be a little careful of this because a lot of times you'll just jump to the primes. Right? The primes, though, these primes are about the mass center. So those are the mass center moments of inertia. But I don't want that. I want about the corner, right? I want about that corner. So there's the corner over there. And then all of our rotations right now, when we do 3D, it's not going to be this case, but when 2D, all of our rotations are about the z-axis, right? And so it's IZ is what I want. And so this is what I want. Oh, I already highlighted it, right? IZ axis, which is 1/3 m times b squared plus h squared, where b is, right, h is there, and then b is there, right? And so in our case, right, let's just calc it. IO is equal to 1/3 our mass, 30 kilograms, 30 times b, so this thing is 2 meters by 2 meters, so it's 2 squared plus 2 squared. Okay. And that is it. And so this ends up being equal to 80. 80 kilograms meters squared. Units on that. I did my mass props. That's all I need to know. Mass center, I mean, I hope you know where the mass center is in there without doing calcs. If you wanted, if you needed, you could do calcs, but it's gonna be right in the middle, right where I have that point drawn. But if you didn't see it, that's fine. Stick to the plan, and you could do the weighted averages, and it would tell you that it was there. Actually, no, you don't. No, there's nothing to weight averages. It's in the middle. It's right in the middle. Okay, that's where it's at. It's in the middle. I'll just tell you that. Oh God. Yeah, I don't know how you do. How do we? Yeah, there's not two objects there. It's in the middle. I mean, it tells you it's in the middle here. Does this tell it's in the middle? Never mind. I hope you know it's in the middle. Okay, if you don't know it's in the middle, that's a problem. Okay, free body diagram, right? So let's draw a free body diagram. So isolate the object, right? What's acting on this sucker? Yep, mass times gravity. Right, so we got that. It's going to act right through the center. Right. Mass times gravity. Right, what else do I got? Reactions, yep. I would just draw them in as positive. OY, OX. And if you could draw them in if you think they're going to be going other directions. You can do it. And then, but then if you draw them in wrong and they turn out to be negative, that means they're in the opposite direction than how you drew them. In this case, I'm just going to draw them. Is that where is it spinning about the left? Yeah. So then I just put them as positive, and if they turn out to be negative, then it means they're negative, right? And so back to that assumption. Anything else acted on that? Oh, there's a moment, right? This thing has a moment up here. You can draw your moment anywhere. If you remember that from statics, I'll just put it out here. Right. It acts the same no matter where it's at. Legs on my moment. That's equal to 10 newton meters. Right. Anything else? I think that's it, right? Those are all our forces. So our free body diagrams, we're set up, ready to go. That's everything. Okay? So then kinematics. Again, when I deal with these types of problems, I need a G. That's what I think to myself. Sometimes it's not that straightforward, but usually it is. I need a G. So I'm going to start at a point that I'm having trouble taking myself serious because these boots are like size 12 and I wear size 10 and then they're just flopping around. So my apologies. So this is serious, right? This is 12.5% of your grade, right? Like, and I'm up here just fucking around in a Santa costume. It doesn't matter to me how you do, right? I don't give a shit. I've already done this. I'm all right. Okay. As you could, yeah, okay, all right. So that's, I haven't even looked at my notes yet. All right. So kinematics. Okay, so again, I go to AG from a point that I know something about, right? I need AG. It shows up in my equations below, right? AG is equal to, what's a good place? O, right? O is not moving. So I'm going to take an O down to G. So this is going to be AO. Thank you. Right. AO. AO. Plus alpha crossed with RG is seen from O minus omega squared times RG is seen from O. Oh, that's what it is. I jumped too far forward. This guy right here 0, right? And that's the other difference between what we did in an example problem in class is omega, it started out as rest, at rest last time. This isn't at rest, right? This one has an omega. The problem statement has this thing moving, right? 4 radians per second, right? Negative 4 radians per second even, right? Negative, because rotating down like that. And so I do have an omega, so I can't cross that omega. When it's at rest, that goes away. When it's not at rest, that doesn't go away. You just leave it in there, right? I don't think you've done one with that yet, but it's easy. You just leave it in there, okay? So then this is equal to AG is equal to alpha in the K direction. Just assume it's positive, and I cross that with RG is seen from O, which is going to be negative 1 in the I, 1 in the I, minus 1 in the J. Is where that's at. Minus omega squared times 1 in the I, minus 1 in the J. Oh, and I know what omega is, so I probably might as well put that in there. This omega is given to us at negative 4. Yeah, negative 4 squared. Hey, am I doing all right? I'm doing okay? Okay. Carry out these cross products, lump-like terms. I'm going to jump down to it. AG ends up being equal to alpha minus 16 in the I plus alpha plus 16 in the J. So I just carried all that stuff out, lumped my I's, lumped my J's. Again, if you're doing these vectors with your calculator and stuff, get to this point, right? Get to this point so I know what it is that you put in. You can put it in your vector form if you want, but you got to get to a point where I know what you put in your calculator. You can't just it's now I'm having trouble because I'm looking at you guys like I was like what the it's just like holy shit. I'll tell you one thing. As I get older, my eyebrows are starting to sprout. It's happening. It's real. Like old people get big eyebrows. It's happening to me. As if they weren't big enough, they're getting bigger. Okay, so that's it. So again, just make sure you document everything that you've done, right? And so that I could see if you did it well enough, right? And see if it was just a calculator error or what was happening. So just to point this out, I always like to do this. I say this is my AGX and this is my AGY, right? Because those AGX and AGY show up in our equation down below. So everything that's in the X direction is AGX, everything in the Y direction is AGY, right? And they come down. Now we're ready for my equations of motion. My equations of motion. Sum of the forces in the X direction is equal to MAGX. I told you we were going to see that, right? And so we look at it, I just come up, free body diagram. What's happening in the X? OX. That's it. They go OX, right? Is equal to mass is 30, right? And AGX we just determined to be alpha minus 16. That's as far as I can get. As far as I can go with it, right? I got too many unknowns. I don't know OX and I don't know alpha. All right? Sum of the forces in the Y is equal to MAGY. And then write them out. Everything that's happening in the Y. I got negative MG going down, and I got positive OY going up. So I got OY minus mg is equal to 30 again is my mass, and it's alpha plus 16. Go. And you're like, oh, still can't do it. Picked up a new unknown, picked up another equation, picked up a new unknown, picked up OY. Right? So now I got one more equation to use. Sum my moments, right? If I sum my moments, I set my I. I've already determined I'm going to do it about a fixed point. And so I've set it up around the fixed point, right? And so I'm going to sum my moments about the fixed point because my I is about the fixed point. Could you do it about this mass center? Absolutely. But if you did it around the mass center, then your reactions show up in your moment equation. Totally fine, though. It's just a system of equations, just a little bit more complicated. If you do it this way, your alpha pops right out of it. If you do it the other way, you would have 3 equations, 3 unknowns. TI-89 would do that shit all day long, right? But then doing it by hand, you don't necessarily want to do 3 equations and 3 unknowns where they're all linked, right? And so maybe doing it around the fixed point makes your life a little bit easier. But if you didn't do it, just stick to the plan. You'll be just fine. Okay, so last one, sum of the moments about O is equal to IO times alpha, right? And so my moments, I got a positive 10 Newton meters, right? Positive 10 Newton meters, positive because I roll my fingers, my thumb's coming out, so that's positive 10, right? Can't forget that guy, it's there, right? 10 Newton meters. And then I got the moment due to the gravity, right? I got this guy, right? And so that's gonna be mass times gravity times this moment arm, and that moment arm is just 1, right? You could do R cross F if you wanted to, right? But I'm just gonna use my brain, my brilliant brain. And then is that gonna be a negative or a positive moment the gravity is causing? Negative, right? Yeah, because you just look at it, the fixed point, and then mg is making it curl like this, and so it's gonna be a negative. So it's gonna be minus 30 is our mass, gravity is 9.81, and then I need to multiply by the moment arm, and my moment arm is 1 in this case. And that's equal to 80 alpha. So that's what I'm saying right there is I could solve alpha, right? Because there is no other thing. It's just alphas in that last equation, right? And you take that and put it in. But I don't know if you picked up on this, but my goal for solving all these things is I just write all the equations and I just get a system of equations, and then it's just algebra, right? Hopefully you picked up on that at this point, right? And then I kind of skip over this part because I'm not here to teach you algebra. I'm here to tell you to use your calculator, right? I'm here to tell you to do that, right? And so then, right, this point's just algebra, and you solve for alpha. Alpha ends up being equal to negative 3.55 rads per second squared. OX ends up being equal to negative 586.6 newtons. And OY ends up being equal to 667.69 newtons. Right? And there's the answer. Right? And so again, what do these things mean, right? Alpha is negative, means that it's not positive, it's negative. I assumed it was positive, but it turned out to be negative. And same thing with OX, right? I assumed to be positive, but it turned out to be negative. So OX is actually gonna be, right? It's acting this way, OY is acting up like this, right? And the thing is rotating with the negative alpha, which your intuition should say absolutely it's going to negative alpha. Questions? Questions? You guys are really silent today. Just taking my belt off. just derobing a little bit. I'm gonna pass out. I'm gonna do. That's wet. That's okay. My bad. See, there's steam coming off. I'm pretty sure my buddy did not intend me to sweat all over it. So don't tell him. Don't tell him that I did that. I mean, I'll wash it. I think I should wash it. But Well, the gross part is I know him. Actually, he's best legs 97. Wow. Cool story, huh? Yeah, I was best legs 96, and he was a year after me, best legs 97. I'm pretty sure he sweated in it too. We're just sharing.
I don't know.
That's how you know you're true friends.
The true friends. We just share sweaty costumes together. Okay. Extra credit? Extra credit? Yeah? Take a look at it. Extra credit. I'm not actually going to do it. I'm just going to show you it. It was involved, right? And again, it's extra credit because it's a little bit more difficult, right? Because you have to know everything else, and then you have a little extra time, you do this. This one has kind of a trick. You have to do work energy, right? You have to do work energy to begin with to figure out what the omega is when it gets down at the bottom. You need to figure out what it's doing when it gets to the bottom. So it was kind of a trick. It was kind of a trick that you had to do a little work energy to determine what the omega is when it gets down to state 2, right? And so then what I did is I just did, right? T1 plus V1 plus work 1 over 2 is equal to T2 plus V2. And the only thing you get to cross out is V2, right? Because, again, I like to define my datum so that there's 0 down at the bottom, right? And so it has kinetic energy at the beginning, 1/2 I omega squared, because they tell us what it is up at the top, right? And then it has MGH, so you got to do a little bit of stuff over here, right? Figure out where the mass center was at 1. When it rotates down, it's at square root of 2 down. And so then how the height between is what it was before and what it was after, which would be 0.41. I like your commitment, Mark. Yeah. Can't see anything. Ah, yeah. Who are you? What are you? You Bob Ross? No, you're just a hippie. He's a hippie. Here, sign this thing. Sign this. Okay, so you got to do, so this is the kinetic energy, right? And again, if you're trying to do energy about a fixed point, if you do energy about a fixed point, then you can leave out the VG squared. You can leave out the VG squared and just the IO omega squared. Okay, plus the MGH, that's what that is. And then the moment does work as well. There's an applied moment, so it does work, and it's negative here because it's going opposite the direction of motion, right? M is going up that way, but it's falling down that way, so it's doing negative and it's pulling energy and it's slowing it down, right? It's slowing it down. So I got the negative moment times pi over 4 would be the distance over, that rotation is just 90 degrees. Is that 90 degrees? 45 degrees, whatever pi over 4 is. And that's equal to 1/2 I O omega squared, okay? And so then you just plug in all your values and it tells you what omega 2 is. So I know what the omega is when it's down at the bottom, right? It's not 0 when it gets down to the bottom. It's something, okay? So then I do the same thing. I go through, I do my kinematics. Now, though, the kinematics I'm doing are these kinematics from here. Bless you, bless you. Yeah. From here to here, right? I got to do the kinematics there. I need the AG. And so, again, when you solve these problems, I can't use the kinematics from up above, because that's a different state, right? It doesn't look like that anymore. It's now fallen down. That's what's really unfortunate about these kinematics when you do it. When you F equals MA, they're only valid at the instant you see it. A millisecond later, omega is no longer 4. It's sped up, right? And then the moment is actually going to be applying to it. Right? It's just milliseconds. It only applies right there. Work energy, though, it works the whole time. It's great. Okay. You just look at the two states. But you do have to make sure your kinematics are right. So the kinematics have changed now when you're down at the bottom. So you have the updated kinematics with this. Okay, again, that's AGX and AGY. Some of the force is X, some of the force is Y. Some of the moments about O, right? And in this case, the only moment that ends up being about O is that applied moment. There's no other moment there because the gravity is lined up with it. And then, yeah, that's it. That's the only other force. There's no moment arm on gravity at this point. It's lined up with O, so there's nothing there. And so you go through, you solve for your alpha, and then substitute back in. Or there's 3 equations and 3 unknowns. I think I did it right. So that one, the trick there, right? The trick there was just doing work energy to start with. Cool. Questions, concerns, nervous? Sure? It's not too bad. Is there any pizza left, or is it all gone? Good job. Good job, everyone. I do have extra Tootsie Pops, though, if you want. Yeah, you bet. It's a good time, guys. We partied. What's that? We got a picture already. Sorry, dude. More Tootsie Pops.
For on this first one, the last part, when you get omega A, is that like the rotation of A around E?
It's just omega up that bottom.
Okay.
And so you get it from going from here to the known there, and then I'll tell you how the body has to rotate.
Oh, did you just skip that step?
Oh, I did it. I said it was right here. Omega A is VA over R. So R times omega is V.
Yeah.
Right?
I
The rolling
thought,
wheel.
I thought that was just for like parts on the outside because A's in the middle.
Yeah, so E is 0. Yeah. Yeah, go for it, dude.
Thank you, Dr. Eric.
Oh, wait. Oh, yeah, a Boy Scout. Is that real? Is that
It's
legit?
real, it's
Hell
real.
yeah, hell yeah, man.
You got a pizza.
I don't. Somebody, right there. There's one on the desk there. Mark your other one. No, I got it. So, did you sign that too? If you dressed up, you signed that. Okay. So it's just R times omega. If you have a wheel that's rolling and you know the velocity of the center, then you can calculate what omega is. It's just going to be. It's just going to be the velocity. It's just velocity divided by 3. So R times omega will tell you the velocity of A. And then so I just kind of flipped it. R times omega is equal to V, and so I just took the R and put it on that side.
But if your wheel wasn't spinning, if it was just moving without spinning,
If it was dragging, but if it was dragging, like sliding along, then the velocity of A would be the same as the velocity of B, and it wouldn't be turning. But the whole point is like of rolling wheels is that they because it's a rolling wheel.
okay, I got it.
Does that make sense?
yeah, I was just
If you were thinking if it was dragging.
I was just thinking like if nothing was
Thank you very much.
like if there was nothing on the ground, like if it wasn't touching the ground or something.
Yeah. If it wasn't touching the ground and it didn't have
Yeah.
the ground there to make it roll, then yes, what you were saying. But the fact the ground's there is making it roll, then it does that. Yep. Another one? You guys get one? You get one of these? There you go.
On that last problem where it falls, I solved it using kinematics, but when originally I did the integral from 45.
Oh, you did with the integrals, sure.
Yeah, from
Yeah.
45 to 90.
Yeah.
But that didn't work. You had to do from 350 to 720 for some reason.
I'd have to see it. There's something was off.
Okay.
Yeah, but you can. You're right. You could do integrals. You just got to keep in mind, like as you're integrating, that moment is changing, right? Because the forces, you get the moment arm is changing as it's dropping and stuff like that. Work energy is better though.
I agree. I would do it
Now
that
that you
way,
see
but,
it, yeah.
like,
Yeah. But it should work what you were doing. You just got to be really more careful with your integrals and things like that. But I'm assuming you made a little bit of a mistake in there somewhere is why I ended up that way.
And I ended up fixing it though. It's just like why does the negative matter? Because like it like cosine is positive on the right half of the circle. That was my logic behind it.
Yeah.
And so I don't understand why going from 45 to 90 would be different than going from 350.
Yeah.
350.
Yeah. I'm not sure. I'd have to see it, man. Yeah. If you want to send it to me, I can look at it.
Okay.
Yeah.
Thank you.
Why we used the I about the z-axis. Was it because we were looking for the horizontal and vertical components?
Yep. So all of our rotations, right? We're fixing it to the plane, right? It's all planar stuff.
Yeah.
So we have X and then Y and then Z's coming out, right? And so then we're doing it about like the Z, right? So it's the moment of inertia about that corner point.
Yeah.
And so that's why we use the IZ axis, because that's about this point. IZ prime is through the center of mass.
Gotcha.
And so if you were going to sum your moments about the center of mass, then you would use IZ prime. Right, you'd use the IZ prime, but since we're doing it about the corner, then you use the IZ. So you got to be really careful about that because that's a common mistake. People grab the wrong one of those.
Gotcha. Okay, perfect. Thank you.
Cool?
I'm just double checking. We're good. I'm coming to your office on Friday at 11 a.m.
You know, I had that in there. I was like, who's coming at Friday at 11? I didn't know.
The hippie.
Yeah. I had it at Wednesday 11, which didn't make sense. No, that's okay. Friday at 11. Yep, now it makes more sense.
Thanks.
Yep. Thanks for reminding me. I would have blown you off. Yeah.
Okay.
Yep.
I have a question about the moments. So like some moments equal to.
Hey, thanks. Yeah, I don't know where those go, but like, just throw them in the street somewhere, right? Someone will pick them up. Yeah. Good idea.
So you have some moments equal to a moment or area moment equation, right? So I was just curious, when will we need to do the planar one? Because we always do it about an object or at the center of gravity.
Just a plane. No. Like a not fixed point and a not center mass. No, I won't do one of those.
Okay. So it's
Yeah.
going to be fixed point or
Yeah,
something.
because if you did do that, you could just see it's HG plus R cross MAG, but I don't think we've done one of those like that where we don't have a fixed
I
point.
don't know what HG is.
Well, there is one that's it ends up being R cross MAG is what HG is I omega squared, IG omega squared in planar, and then the other part is R cross MAG. But I don't think we've ever done one like that.
Okay.
Maybe I'll stick you with it. I'll get you. That's a good. Thanks for the weakness. So I've discovered your weakness. So yeah.
And then we don't need to know the work energy, right? That's just.
Nope, that's next time. And then I just threw it in here as extra credit on this one.
Oh, and then the first one for the extra credit, I didn't do the rolling wheel one. I just like continue to solve it with accelerations.
Yeah, that's fine. Yep. I was just saying, like, if you were in a hurry, that's where, like,
That'd be helpful.
Yeah, it'd be helpful just to be able to kind of look at it and say, oh, rolling wheel, and then go from that.
And the bottom point only accelerates in the J direction.
Yes, yep, because if it's accelerating that way, it'd be spinning out. And so it's not, so it just touches and then goes. And then so it has, all it has is centripetal.
Okay, thank you.
Yep, you bet. Yep.
I'll see you on Tuesday.
Yep. Have a good time in New York. You've been there before. Has Manus been there before?
I don't think. Oh, he might have been there with his family, but his mates going there, so you know they had accommodation, so it just lines up perfectly.
Yeah, that's awesome.
Yeah, just
Cool.
trying to see as much as I can.
Oh, yeah, you bet. Before you gotta go back, dude.
Yeah.
Go, Wings. Have a good time.
See you later.
Yep.
It is 6:37.
Huh? How's it going, guys? Good. There you go.